Hello everyone, I am Meenakshi Chauhan working as an assistant professor IT department Kite Group of Institution Gajiwala. In this lecture I will be discussing about assembler directives. So let's get started. Now what is an assembler directive? In assembly language we have two types of statements. One is executable statement, second assembler directives. Executable statements, these are statements to be executed by the processor. These statements represent the instructions which are going to be executed by the processor. Whereas assembler directives, these are statements that direct the assembler to do something. These statements are only for assembler. As the name suggests that it directs the assembler to do a task. So assembler directives are the instructions to the assembler only concerning the program being assembled. The assembler directive are also called pseudo instructions because these are not the actual instruction of the processor. These does not belong to the instruction set of the processor. These are only for assembler. So these instructions are named as pseudo instructions or pseudo opcodes. So the instructions are neither translated to machine code or assigned any memory location in the object file. These instruction will not be converted into the machine code, then that's why these statements will not be stored in memory. So assembler directives are effective only during assembly of a program, but they do not generate any code that is machine executable. Instructions are machine executable instructions, but pseudo instructions, or we can say assembler directives, are only for assembler that direct to the assembler to perform some task. And what are these tasks? So some functions of assembler directives are listed below. These directives can be used to show beginning of the program or end of the program. And these directives are also can be used to provide storage location to the data. Some assembler directives are used to give values to the variables, or some assembler directives can be used to define the start and end of the different segments, procedures, or macros. We will see some examples of assembler directives. So here we have a list of assembler directives. First is ORG, that is related to origin. So ORG, and then we will mention some address. This assembler directive defines the next block of instruction should be stored in memory location starting at the mentioned address. Second is end. So this assembler directive will show the end of the assembly program. Next is EQU. This is equivalent to equate. So through this assembler directive, we can assign a value to a name, variable name, or assign a value to some symbol. This assembler directive is used to equate something. With the help of this, we can assign values to some variable or as well as some symbol. So here you can see that port 1 is equal to 0, 1 value in hexadecimal. So here we are assigning 0, 1 value to port 1. Or we can assign some address to. So here we are assigning a 2099 address to in buff variable. Next assembler directive is dv, define byte. Through this assembler directive, we can assign some byte, or we can initialize an area byte by byte. So we can provide a single byte or a set of bytes. And this directive is used for purpose of allocating and initializing single or multiple data bytes. Assembled bytes of data are stored in successive memory locations. If we are assigning multiple bytes through this assembler directive, for example, in this example, suppose we are assigning 3 bytes here with the values 30, 52 and 35. So these value or these bytes will be allocated in memory in a continuous location. Suppose the first byte is at address 1000. Then next byte will be at 1001 and next at 1002. And here we have used two levels. One is data and second is area. So these levels are optional. We can directly assign any byte. So we can use dv, suppose 15h. So here we are assigning a byte with value 15 without label. Next is defining word. We can define the word. Initialize an area 2 bytes at a time if the word size of 2 byte. In case of 8085 microprocessor, the word size is 1. So this assembler directive will define only 1 byte at a time. Next assembler directive is ds, define storage. So here we can define storage, how many locations will be used by some level. So we can allocate a number of locations with the help of ds to a variable. So it reserves a specified number of memory locations. For example, here out buff level, then ds4. So it will allocate 4 memory location to out buff. So next assembler directive is macro. Macro is basically used to define the macro. Macro will show the beginning of macro. Here a name step of the macro is given. Then macro keyword to specify that these statements belong to a macro, or we are defining a macro with some argument. Next we will specify the statements related to that macro, and next we will define the end of macro. So macro word is used as a assembler directive to specify the macro is being defined. It shows the beginning of macro along with the defining name and parameters. In this example, the micro name is step and M shows the end of macro. So in this way, we can use a different assembler directives in assembly programs. These assembler directives are different from the instruction of the processor. In this lecture, we discussed about various assembler directives. Assembler directives are the, we can say, keywords which are given to assembler to perform some specific task. And these statements are only for assembler. These statements, or we can say assembler directives, are called pseudo instructions. And these are not converted into machine code. The content of this lecture was taken from Microprocessor Architecture Programming and Application with 8085, written by Sir Ramesh S. Goenka. Thank you. Happy learning.